Hey everybody, this is another late installment of our previews of Short Takes 115. So this is Electric Potential 3. This should have come out a couple of days ago. Apologies, but anyway. So in this class, I guess it's not a preview anymore, now is a review. So we spent quite a bit of time talking about point charges and the corresponding forces between pairs of charges, electric field, electric potential, and potential energy of pairs of charges. And a particular example that came up towards the end of the lecture, which is really important for considerations in biology, is the case of a dipole. So a dipole is what you have when you have a configuration, when you have a negative charge that is minus q and a positive charge that is plus q. So they're equal and opposite, so equal in magnitude in charge and opposite in sign. And so you have this type of field configuration where you have field lines that leave the positive charge and go toward the negative charge. This diagram should be continued, of course. I was just a little lazy here and drew only 3 field lines. Notice how the field lines originate at the positive charge and go to the negative charge. And then the equipotentials have this shape here that I sketched out. So there's this line should be exactly in the middle. And if you add the potential due to this charge plus the potential due to this charge, you will get that at the middle point it is 0. So it exactly cancels out when you're at an equidistant point from both charges. So any point in space that is at the same distance from this charge and this charge will give you a 0 total potential. That is a potential that will be experienced by another charge that you might bring in from outside. Now, this system itself has a potential energy that is non-zero. If you were to have these two charges sitting there and you release them, then they would fall towards each other. And so there is some potential energy in the system, just the two charges by themselves. So that's something that we discussed in class as well. So to be distinguished then from what these two charges might do on some other charge that is brought out from the outside. When you have a dipole like this, we often define what we call a dipole moment. And this is a vector and it points from the negative charge to the positive charge as shown here. So notice how this is different from the electric field, which points from positive to negative. Yeah, so dipole moment always points from negative to positive. And this is useful in biology applications because it turns out that the heart polarizes. So it has more density of positive charges and negative charges in different regions around it. So this is my sketch, my really poor man's sketch of a heart. And this is a massive polarization vector as you see here. So if this is like so, and this vector is pointing from negative charges to positive charges, and you measure with a device with a positive terminal and negative terminal here, you measure the potential difference between these 2 points, then here this terminal would be closer to the more negative charges where the vector originates, and over here you have be closer to the more positive charges, and so this difference here would give you a negative result. So if you flip the terminals, so you put the negative over here and the positive over here, then you would have a positive result. So this is what we saw towards the end of the class, and is really important, like I said, for biological applications. And these are the types of questions that you can expect when talking about dipoles in this class. And that's all I have for you for this particular lecture. We'll do another video for the next lecture that is also missing. So I'll see you in just a bit.